The morning of April 10th, 1943. Over the North Sea, at 23,000 feet, Lieutenant Robert Johnson wrestles with his Republic P-47 Thunderbolt, trying to reach the bomber formation he's supposed to protect. Below him, somewhere in the haze, 300 B-17 flying fortresses drone toward Bremen. His squadron leader's voice crackles through his headset, fragmented, distorted, then gone. Static fills his ears. He twists the frequency dial on his SCR-274 radio set. More static. A fragment of BBC radio bleeds through, someone speaking German. Then silence. Johnson can see the bombers now, tiny specks against the cloud layer, but he cannot talk to them, cannot warn them, cannot coordinate. In 6 minutes, Messerschmitt Bf-109s will tear into that formation from above, and Johnson will watch helplessly as bomber after bomber falls from the sky because the technology that connects him to those crews, the radios, both aircraft carry, simply does not work when it matters most. This is not a story about radios failing. This is a story about a frequency that should have saved thousands of lives, developed years before it was needed, proven effective by another air force, yet abandoned by American military doctrine until the body count became impossible to ignore. By the time the solution was finally adopted in late 1943, over 2,000 American heavy bombers had been shot down over Europe. How many of those crews died in silence, unable to call for help, unable to coordinate their defense, because the men making decisions refused to abandon a system they knew was broken? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The answer begins not in combat, but in a laboratory at Fort Monmouth, New Jersey, in 1939. While Hitler's armies prepared to invade Poland, Army Signal Corps engineers were already experimenting with very high-frequency radio systems. The concept was simple. Move aircraft communications from the crowded high-frequency bands, essentially glorified AM radio, to the clearer VHF spectrum between 100 and 150 MHz. The Signal Corps designated their experimental system the SCR-264. Initial tests showed promise. Voice communications were clearer, less atmospheric interference. The line-of-sight limitation of VHF signals couldn't travel beyond the horizon was actually an advantage for tactical operations, preventing interference from distant stations. But in 1939, American military doctrine had no use for fighter-to-bomber coordination radios. The prevailing belief, codified in countless Air Corps tactical manuals, stated explicitly that modern heavy bombers required no fighter escort. The Boeing B-17 Flying Fortress, bristling with up to 1350 caliber, machine guns in overlapping fields of fire, would defend itself. Tight formation flying would create an impenetrable wall of lead. German fighters wouldn't dare attack. Therefore, sophisticated radio coordination between fighters and bombers was unnecessary. The SCR-264 program was quietly shelved. Meanwhile, across the Atlantic, the Royal Air Force faced a different reality. In the summer of 1940, during the Battle of Britain, RAF Fighter Command discovered that survival depended on coordination. Ground controllers needed to vector Spitfires and Hurricanes toward incoming German bomber formations. Pilots needed to communicate tactical information in real time. The old HF radio sets, prone to interference and unpredictable range, were killing pilots. So the British developed the TR-1133, a VHF radio operating between 100 and 124 MHz. By October 1940, 41 RAF fighter squadrons had been completely re-equipped with VHF. The difference was immediate. Air-to-ground ranges reached 140 miles with aircraft at 20,000 feet. Air-to-air communications were crystal clear at distances exceeding 100 miles. Most importantly, the 4-channel crystal-controlled design meant pilots could switch frequencies instantly, one channel for ground control, one for squadron coordination, one for distress calls, one for navigation. The TR-1133 was not perfect. It was complicated to service, difficult to manufacture, so the British refined it, creating the TR-1143 in 1941. This improved model incorporated crystal control for both transmitter and receiver, eliminating drift. It was smaller, more reliable, easier to maintain. By the end of 1941, the TR-1143 was standard equipment in every frontline RAF fighter. American military observers in Britain saw this. They filed reports. They noted the effectiveness. They understood that VHF coordination had given the RAF a decisive tactical advantage during the Battle of Britain. The reports went to Washington. Nothing changed. In June 1942, the first American heavy bomber units arrived in England, the 97th Bombardment Group, equipped with B-17s. Their radio equipment consisted of the SCR-274N command set, an elaborate collection of transmitters and receivers covering HF frequencies from 3 to 9 MHz. The system was complex: 4 separate transmitters, 3 receivers, dozens of crystals that needed to be changed manually to switch frequencies. Under ideal conditions, the SCR-274 worked adequately. Combat conditions were never ideal. The first American bombing raid occurred on August 17, 1942, a small attack on the Rouen-Sotteville marshalling yards in France. 12 B-17s participated. RAF Spitfires provided close escort. The mission succeeded primarily because it barely entered contested airspace. The real test would come later, when American bombers flew deep into Germany without British escort, relying entirely on their own radios and their own defensive armament to survive. The problems began immediately. Pilots reported that the SCR-274's range varied wildly depending on time of day, solar activity, and atmospheric conditions. Sometimes you could communicate for 200 miles. Other times, you couldn't reach the aircraft flying formation with you. The HF frequencies were crowded with commercial broadcasts, enemy transmissions, and interference from dozens of Allied military users. Coordination became impossible. Fighter pilots flying Republic P-47 Thunderbolts discovered an even worse problem. Their radios frequently malfunctioned completely. On April 15, 1943, during a mission escorting bombers to Paris, the 56th Fighter Group's after-action report noted bluntly, aircraft-to-aircraft communication proved impossible because of VHF radio malfunctions in the Thunderbolts. Wait. VHF? The Thunderbolts weren't supposed to have VHF radios yet. They were equipped with SCR-274 HF sets. The error in the after-action report reveals something crucial. The terminology itself was confused. Pilots and ground crews had begun calling any voice radio VHF because that's what the British used, and the British system worked. The American system, regardless of its actual frequency band, did not. By mid-1943, the crisis was undeniable. The 8th Air Force was attempting deep penetration raids into Germany, Schweinfurt, Regensburg, Bremen. These missions required hundreds of bombers flying in coordinated formations, protected by fighter escorts that could range ahead, warn of attacks, and respond to threats. But the radio equipment made such coordination a fantasy. Consider the mission of August 17, 1943, the first raid on Schweinfurt. 230 B-17s attacked the ball-bearing factories while 146 more hit Regensburg's aircraft plants. The Luftwaffe responded with overwhelming force. 60 bombers were shot down, 17 more were damaged beyond repair, 594 American airmen were killed, wounded, or missing. The after-action reports tell the story. Bomber crews repeatedly stated they could not communicate with their fighter escorts. P-47 Thunderbolts, limited by range, had to turn back at the German border, leaving the bombers vulnerable. The bombers, unable to coordinate among themselves due to radio failures, couldn't mass their defensive fire effectively. Formations broke apart under attack. Isolated bombers were easy prey. The mission planners had assumed that radio coordination would allow damaged bombers to signal for help, fighter escorts to respond to attacks, and group leaders to adjust formations in real time. None of this happened. The radios didn't work. October 14th, 1943, the second Schweinfurt raid. 291 B-17s attacked, 60 were shot down, 17 were damaged beyond repair, another 594 casualties. The month became known as Black October. The self-escorting bomber doctrine lay in ruins. The 8th Air Force suspended deep penetration raids entirely. American bomber losses were unsustainable, averaging over 25% on missions beyond fighter escort range. At that rate, bomber crews had virtually no chance of surviving the required 25-mission tour. The problem was obvious. The solution existed. Yet institutional resistance persisted. The Signal Corps was still pushing their own VHF design, the ARC-V, designated 23 transmitter and R-28 receiver. This set had been under development since 1942. It operated in the VHF range. On paper, it should have worked. In practice, it was a disaster. Operational units in England reported constant failures, sets that cut out mid-mission, receivers that produced nothing but noise, transmitters that drained batteries in minutes. The ARC-V gained a reputation as unreliable equipment that would get pilots killed. Meanwhile, the British TR-1143 continued operating flawlessly in RAF fighters and bombers. American pilots flying on joint missions with the RAF could hear British pilots coordinating attacks, receiving vectors from ground control, warning each other of threats, all with crystal clarity. Then they'd switch back to their own radios and hear static. The cognitive dissonance was profound. How could American engineering, supposed to be the best in the world, produce inferior radio equipment compared to the British? The answer wasn't technical capability. It was institutional pride and bureaucratic inertia. Adopting British radio technology meant admitting that American designs had failed. It meant abandoning years of development work. It meant accepting that sometimes the solution isn't to build something new, but to use what already works. The British, desperate to prevent their TR-1143 factories from becoming single points of failure if bombed, offered to share the design completely. They needed a second manufacturing source. The Americans needed radios that worked. It was obvious. Yet the negotiations dragged on through late 1942 and into 1943, while men died. Finally, in mid-1943, reality forced the decision. The Signal Corps authorized Bendix Aviation Corporation to manufacture an American version of the TR-1143. This wasn't simple copying. The British design used different power voltages, different mounting hardware, and unique British connectors. Bendix engineers had to completely re-engineer the internal layout while maintaining electrical compatibility with the British original. They consolidated the British two-package design into a single unit. They adapted it for 24-volt American aircraft electrical systems versus the British standard. They redesigned the dynamotor power supply. The result was designated SCR-522. The SCR-522 was not elegant. The combined transmitter-receiver unit weighed 22 kilograms. The PE-94 dynamotor power supply added another 16 kilograms. Together, they consumed significant space in aircraft already packed with equipment. But the system worked. 4 crystal-controlled channels, selectable by push-button, operating range of 100 to 156 MHz, transmit power of 12 to 18 watts. Most importantly, it was reliable. Pilots could press a button and talk, and the person on the other end would hear them. Production began in late 1943. The first operational SCR-522 equipped fighters flew combat missions in December 1943. The transformation was immediate and dramatic. For the first time, American fighter pilots could coordinate complex tactical maneuvers in real time. Group leaders could adjust formations during combat. Bombers could call for help and actually receive it. Ground controllers could vector fighters toward threats before those threats materialized. The entire nature of aerial combat changed, not because of new aircraft or weapons, but because of a frequency, because people could finally talk to each other when it mattered. Consider the technical specifications. because they reveal the profound simplicity of the solution. The SCR-522 receiver used a double superheterodyne circuit design with 11 vacuum tubes, 7 in the receiver section, 4 in the transmitter. The crystal-controlled design meant pilots didn't need to manually tune frequencies under combat stress. 4 channels were preset before each mission. Channel A typically linked fighters to their group commander. Channel B connected to bomber formations. Channel C provided ground control frequencies. Channel D was often reserved for direction-finding transmissions or emergency frequencies. A pilot under attack simply pressed button A and said, "Bandits at 3 o'clock high," and every fighter in his group heard it instantly. No static, no interference, no missed warnings. The BC-602 control box mounted on the aircraft's instrument panel provided the interface 4 push buttons, clearly labelled, impossible to confuse. Press, torque, release. That was it. The system was designed for pilots wearing heavy gloves, under combat stress, possibly wounded, in aircraft being shot at. It had to be simple. It had to work every time. And finally, it did. But by December 1943, when the first SCR-522 sets became operational, over 2,000 American heavy bombers had already been shot down over Europe. 20,000 American airmen were dead, wounded, or prisoners. How many of them died because they couldn't coordinate with their fighter escort, because they couldn't warn other aircraft, because they couldn't call for help? The records don't specify. But the after-action reports from those missions tell a consistent story. Unable to contact fighter escort due to radio malfunction, lost visual contact, came under heavy attack. Again and again. The irony cuts deeper when you examine the timeline. The British had operational VHF in 1940. American Signal Corps engineers had initiated VHF development in 1939. The TR-1143 design was proven effective by 1941, yet American bombers didn't receive working VHF radios until late 1943. That's a 3-year gap between the solution existing and being implemented. 3 years during which American doctrine insisted that bombers didn't need sophisticated radio coordination because they could defend themselves. 3 years during which mounting casualties proved the doctrine was suicide. 3 years of institutional resistance to accepting a simple truth. The British had solved this problem, and pride was killing American airmen. January 1944. Lieutenant General James Doolittle assumed command of the 8th Air Force. Doolittle, famous for his 1942 raid on Tokyo, understood tactical reality better than most commanders. He also understood that the SCR-522 had finally given American forces the coordination capability that British fighters had enjoyed since 1940. But technology alone wasn't enough. Doctrine had to change. Doolittle made a controversial decision that horrified bomber crews but would ultimately win the air war. He ordered American fighters to abandon close escort tactics. Instead of staying glued to bomber formations, providing continuous protection, fighters would range far ahead of the bombers, hunting German fighters before they could organize attacks. The key was coordination. Ground-based fighter directors, using radar and radio, would track both friendly and enemy formations. They would vector American fighters toward assembling Luftwaffe units. The fighters would attack German formations while they were still climbing to altitude, before they could reach the bombers. This aggressive, offensive counter-air doctrine terrified bomber crews who felt abandoned. But it worked, because for the first time, American forces could coordinate complex operations in real time across dozens of miles. The transformation reached its peak during Operation Argument in February 1944, known as Big Week. This was the first truly coordinated massed aerial campaign of the war. Beginning February 20th, the 8th Air Force and the newly operational 15th Air Force in Italy launched simultaneous attacks on German aircraft production facilities. The scale was unprecedented, over 3,000 bomber sorties in 7 days. On February 20th alone, over 1,000 American heavy bombers attacked targets across Germany. This wasn't possible before the SCR-522. You cannot coordinate 1,000 aircraft operating over hundreds of miles of sky using unreliable HF radios. The formations would dissolve into chaos. But with VHF coordination, the operation functioned like a complex machine. Fighter groups handed bomber formations to each other using radio coordination. P-47 Thunderbolts escorted bombers to the German border, then radioed ahead to longer-range P-38 Lightning groups that took over escort duties. P-51 Mustangs, with the longest range, flew all the way to targets deep in Germany. Ground controllers monitored everything, adjusting coverage based on real-time intelligence about Luftwaffe fighter concentrations. When German fighters appeared, American fighters were vectored to intercept before the Germans could organize coordinated attacks. The Luftwaffe expected to slaughter the massive formations. Instead, German losses exceeded 350 fighters destroyed in 1 week. More critically, they lost dozens of experienced pilots' irreplaceable expertise that the Luftwaffe never recovered. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The tactical revolution extended beyond strategic bombing. Forward Air Controllers FACs began using SCR-522 radios to direct tactical air support. By June 1944, during the Normandy invasion, the system had evolved into sophisticated close air support coordination. Liaison aircraft, small Stinson L-5 Sentinel observation planes, nicknamed horseflies, carried SCR-522 radios and roamed ahead of advancing ground forces. When they spotted German positions, they radioed coordinates to fighter bombers, orbiting in designated cab ranks. The fighters would attack within minutes. This was impossible before reliable VHF. You cannot direct airstrikes with radios that don't work. Allied tanks received VHF radios. At least 10 tanks in every armoured division were equipped with SCR-522 sets that could talk directly to aircraft overhead. Tankers could request immediate air support. Pilots could warn tankers about enemy positions ahead. The coordination between ground and air forces reached levels that seemed like science fiction compared to 1942's chaos. All because of a frequency. Because engineers finally built a radio that worked, using a design that had existed for years. The German military noticed. Luftwaffe intelligence reports from 1944 show acute awareness that American coordination had become devastatingly effective. German fighters could no longer mass for attacks without American ground controllers, spotting the formations and vectoring in P-51s before the German fighters even reached their targets. The Luftwaffe's tactical doctrine, developed when air-to-air coordination was primitive, assumed they could assemble large fighter formations that would overwhelm bomber defensive fire through sheer numbers. That doctrine collapsed when the enemy could see you forming up and send fighters to hit you while you were still climbing to altitude and burning fuel. By April 1945, the Luftwaffe was effectively destroyed. Not primarily because Germany ran out of aircraft, German fighter production actually increased through late 1944. They were destroyed because they couldn't survive against an enemy that coordinated every move, vectored fighters with real-time intelligence, and operated with seamless air-ground integration. An enemy that could talk to each other clearly, instantly, reliably. An enemy that had finally adopted the same VHF radio technology the British had used since 1940. The statistics reveal the cost in stark terms. Between January 1943 and December 1943, before widespread SCR-522 deployment, the 8th Air Force lost approximately 2,100 heavy bombers in combat. This represents roughly 21,000 aircrew casualties. After widespread VHF deployment in early 1944 through May 1945, the 8th Air Force lost approximately 2,700 bombers, despite flying 3 times as many missions. The loss rate per mission dropped by over 60%. Not all of this improvement came from radio coordination, longer-range escort fighters, better tactics, and Luftwaffe attrition all contributed. But the after-action reports from 1944 consistently note successful coordination between bombers and fighters, effective warnings about enemy attacks, and ability to call for help when needed. The 1943 reports note, opposite. Radio coordination worked in 1944. It didn't in 1943. The difference was VHF. Consider what this meant for individual crews. Technical Sergeant William Thompson, a radio operator on a B-17 in the 91st Bombardment Group, kept a diary. His entry from October 9, 1943, after a mission to Gdynia, Poland, reads, "Lost number 3 engine over target. Fell behind formation. Called for fighter escort on all frequencies. No response, static only. Enemy fighters attacked continuously for 40 minutes until we reached the coast. Tail gunner killed, waist gunner badly wounded. Made emergency landing in Sweden. If we could have talked to our escorts, they would have come. They didn't know we needed help. Thompson's aircraft was one of the lucky ones they survived." His entry doesn't mention the bombers that didn't make it to Sweden, the ones that fell into the Baltic Sea because they couldn't call for help, because the radios that were supposed to save them operated on frequencies that didn't work when you needed them most. By contrast, Lieutenant Colonel Hubert Zemke, who took command of the 479th Fighter Group in August 1944, wrote in his mission reports about the SCR-522's effectiveness. The ability to coordinate with bomber formations and receive real-time intelligence from ground control has fundamentally altered fighter tactics. We can now respond to threats before they develop, rather than react after bombers are already under attack. This is not an incremental improvement. It is a complete transformation of operational capability. Zemke's group flew P-38 Lightnings and later P-51 Mustangs, all equipped with SCR-522 radios. His combat record bears out his assessment. The 479th achieved one of the highest kill-to-loss ratios of any 8th Air Force fighter group, not because their pilots were necessarily more skilled, but because they could coordinate their attacks with unprecedented precision. The technological specifications of the SCR-522 reveal how simple the solution actually was. The transmitter section used 4 vacuum tubes, 2 VT-118 tubes in the power amplifier stage, producing the final RF output, plus 2 VT-134 tubes in the frequency multiplier stages. The receiver used 7 tubes in a standard superheterodyne circuit. Total tube count, 11. This wasn't exotic technology. These were standard vacuum tubes used in dozens of other military applications. The crystal-controlled oscillator circuits weren't revolutionary. They were proven technology borrowed directly from commercial radio design. The modulation transformer that converted voice signals into radio frequency variations was simple audio engineering. There was nothing in the SCR-522 that couldn't have been built in 1940. The British proved this by actually building it in 1940. What delayed American adoption wasn't technical impossibility. It was the belief that such a system wasn't necessary. American pre-war doctrine stated explicitly that bomber formations, properly organized and flown, could defend themselves without fighter escort. This belief was encoded in training manuals, tactical publications, and procurement priorities. VHF radio development was cancelled in 1939, not because engineers couldn't build it, but because Air Corps planners didn't think they needed it. The doctrine said bombers were self-sufficient. Therefore, sophisticated coordination radios between fighters and bombers were unnecessary. The logic was circular and ultimately fatal. Even after combat experience in 1942 and early 1943 proved the doctrine wrong, institutional resistance persisted. The Signal Corps continued pushing their own ARC-5 VHF design, despite field reports of constant failures. Adopting the British TR-1143 meant admitting that American engineering had produced inferior equipment. It meant scrapping years of development work. It meant accepting help from an ally many American officers still viewed with post-colonial condescension. Pride has killed more soldiers than enemy action ever could. The human cost becomes personal when you examine individual cases. Second Lieutenant Robert Morgan flew B-17s with the 306th Bombardment Group. His aircraft, named Memphis Belle, became famous for completing 25 missions, a feat so rare in early 1943 that it became the subject of a War Department documentary. Morgan's memoir, written decades after the war, describes mission after mission where radio coordination failed at critical moments. During the June 13, 1943 raid on Bremen, his formation came under heavy fighter attack. Morgan tried to call for help from the P-47, escort. His radio produced nothing but static. He tried all frequencies. Nothing. He watched German fighters methodically pick off bombers one by one while American fighters flew somewhere overhead, unaware that the bombers they were supposed to protect were being slaughtered. Memphis Belle survived that mission, but 5 other aircraft from their formation didn't. 44 men died because they couldn't call for help. Morgan wrote, "We had the best radios American industry could produce. They didn't work. The British had radios that did work. Why weren't we using them?" That question haunted me for years. The answer, I eventually learned, was that we were too proud to admit the British had solved a problem we couldn't. So men died while we stubbornly insisted on using equipment that didn't work, because it was American equipment. The SCR-522 itself was not without flaws. The dynamotor power supply was notoriously heavy and consumed significant battery power 11.5 amperes for the transmitter, 11.1 amperes for the receiver at 28 volts. In smaller fighters like the P-51 Mustang, the electrical load sometimes caused problems with other systems. The crystal-controlled channel design meant you were limited to 4 preset frequencies. If you needed to communicate on a different frequency, you had to land, replace the crystals, and retune the set. This wasn't something pilots could do in flight. The range was limited to line of sight roughly 200 miles maximum at high altitude, far less near the ground. These were real limitations, but they were acceptable limitations. The SCR-522 was reliable. It worked when you needed it. Voice quality was excellent. Pilots could understand each other clearly, even in noisy aircraft. The push-button channel selection meant switching frequencies took 1 second instead of minutes of manual tuning. Most importantly, when you pressed the transmit button and spoke, the person on the other end heard you. This seems like a trivial requirement, but it was the one requirement the earlier VHF radios consistently failed to meet. The maintenance burden was substantial. Each SCR-522 required regular servicing, tube testing, crystal calibration, alignment of the receiver and transmitter circuits. At the height of operations in 1944, the 8th Air Force had over 2,000 fighters and bombers, equipped with SCR-522 radios. That's over 2,000 complex electronic systems requiring constant maintenance. Photographs from 8th Air Force bases show repair shops dedicated entirely to radio equipment. Technicians worked around the clock, testing, repairing, and certifying radios for combat operations. One photograph shows a radio mechanic working in a makeshift shop constructed from a shipping crate. The shop isn't tall enough for him to stand fully upright. He's hunched over an SCR-522, spread across a workbench, test equipment mounted on the wall behind him, the heavy dynamotor power supply at his feet. This anonymous technician, whose name we'll never know, was as crucial to Allied victory as any fighter ace. Without technicians like him ensuring radios worked, the entire coordination system collapsed. The scale of production reveals how critical the system became. Bendix Aviation, the primary manufacturer, produced over 33,000 SCR-522 sets between late 1943 and 1945. At peak production, they were building over 1,000 units per month. This wasn't just for American aircraft. The British RAF also adopted the SCR-522 as the TR-5043, using it alongside their own TR-1143 sets. The standardization meant American and British aircraft could communicate directly without frequency conversion equipment. During combined operations, this interoperability proved invaluable. The tactical applications extended far beyond bomber escort. Night fighters used SCR-522 radios to coordinate with ground-based radar controllers hunting German night bombers. The system worked equally well, In darkness, voice radio doesn't require visual contact. Reconnaissance aircraft carried SCR-522 sets to report observations immediately, rather than waiting until they returned to base. Photo reconnaissance pilots flying unarmed Mosquitoes or modified P-38s deep into Germany could warn fighter escorts about enemy interceptors, allowing the escorts to position for defense. Search and rescue operations used VHF to coordinate rescue aircraft, escort fighters, and surface vessels. Downed pilots with handheld emergency radios could contact aircraft overhead directly, guiding rescuers to their position. This saved hundreds of lives, pilots who would have been captured or killed if rescuers had to search blindly. The Germans understood what was happening. Luftwaffe intelligence reports from 1944 show detailed analysis of Allied coordination procedures. They identified the push-button frequency-changing characteristic of American VHF radios. They noted the standardized call sign procedures. They attempted to jam Allied communications, but VHF jamming required powerful ground-based transmitters that had to be positioned close to the battle area. Difficult when the battle area was over Germany and Allied aircraft would simply bomb the jammers. The Luftwaffe also attempted to listen to Allied VHF communications for tactical intelligence, and sometimes succeeded. But even when German controllers knew Allied fighter positions, they couldn't effectively counter attacks because Luftwaffe fighters lacked equivalent coordination capability. German aircraft still relied primarily on HF radios for air-to-ground communication, with all the same limitations that had plagued American forces in 1942 and 43. The Luftwaffe never developed an equivalent to the SCR-522. By the time they recognized its importance, German industrial capacity was collapsing under Allied bombardment. They couldn't manufacture the systems, even if they'd wanted to. The psychological impact on German pilots was severe. Luftwaffe veterans' accounts from late 1944 and early 1945 repeatedly mention the sense of fighting a coordinated enemy they couldn't match. German fighters would laboriously climb to altitude, forming up for an attack on bomber formations. Before they could execute their attack, American escort fighters would appear vectored to be intercepted by ground controllers who'd watched the German formation assembling on radar and directed fighters to the exact position. The ambush would scatter the German formation before they could engage the bombers. This happened repeatedly. German pilots felt like they were fighting an enemy that could see everything and coordinate perfectly while they operated in isolation. This wasn't entirely true. Allied coordination wasn't perfect, and German pilots did achieve successes, but the perception reveals the psychological weight of technological disadvantage. When your enemy can talk to each other and you can't, every engagement feels like walking into a trap. The aftermath of the war revealed the full scope of what VHF coordination had enabled. Allied strategic bombing succeeded not primarily because bombers were tough, they weren't tough enough to survive without escort, and not because escort fighters were somehow superior to German fighters. Aircraft performance was roughly equivalent by late war. Strategic bombing succeeded because the Allies achieved air superiority through coordinated operations that the Luftwaffe couldn't counter. VHF radio was the nervous system that made coordination possible. Without it, massed bomber formations would have remained vulnerable to German and fighter attacks. Losses would have remained unsustainable. The strategic bombing campaign would have failed or been scaled back dramatically. The war would have lasted longer. More people would have died. Yet the technology that enabled this existed in 1940. The British proved it worked in combat during the Battle of Britain. American engineers were capable of building equivalent systems. They eventually did. What delayed adoption for 3 years wasn't technical limitation. It was institutional failure. The failure to question doctrine when combat experience contradicted it. The failure to adopt proven technology because it was developed elsewhere. The failure to prioritize lives over pride. Consider the alternative history. If American forces had adopted VHF radio in 1941, equipped bomber and fighter units during their training in the United States, and arrived in England in 1942 with working coordination systems, how many missions would have succeeded that instead failed? How many bombers would have survived that were shot down? How many of the 20,000 airmen killed in 1943 would have lived to return home? We can't calculate exact numbers, but the after-action reports tell us that lack of coordination was a primary factor in mission failures throughout 1943. Radio malfunctions are mentioned in report after report. Inability to contact escorts, inability to warn other aircraft, inability to call for help. These weren't rare occurrences. They were routine. The men who died in that gap between solution and implementation deserve more than statistics. They were specific people. Second Lieutenant Charles Brown, killed over Bremen on June 13, 1943, when his damaged bomber fell out of formation and couldn't call for escort support. Staff Sergeant James Miller, killed over Schweinfurt on August 17, 1943, in a bomber that broke formation under attack and was lost with all crew. Technical Sergeant Robert Williams, killed over Münster on October 10, 1943, when German fighters attacked while American escort fighters flew overhead, unaware of the attack because radio coordination failed. These men had families. They had futures. They died in part because the organization that sent them into combat refused to equip them with technology that could have saved them. The engineers who developed VHF radio, both British and American, did their jobs. They created systems that worked. The manufacturing workers at Bendix and other contractors did their jobs. They built over 33,000 radios in less than 2 years once production was authorized. The technicians maintaining equipment in the field did their jobs. They kept complex electronic systems operational under difficult conditions. The failure wasn't at the technical or tactical level. The failure was strategic and institutional. The failure belonged to the commanders and planners who clung to doctrine that combat had proven wrong, who refused to adopt proven technology because of pride, who valued institutional continuity over the lives of the men they commanded. There's a photograph from 1944 that captures something essential about this story. It shows an 8th Air Force radio technician in England working on an SCR 522 in a makeshift repair facility. The shop was built from a wooden shipping crate. It's not tall enough for him to stand fully upright. He's hunched over the radio, which is spread out on a rough wooden bench. Behind him on the crate wall, someone has mounted test equipment, ABC 602 control box, a dynamotor, spare tubes in racks. At his feet sits the heavy PE-94 power supply. The technician is young, maybe 20. He's wearing coveralls and a work cap. His hands are on the radio chassis. He's looking at a schematic diagram spread across his lap. There's mud on his boots. The light is dim, a single bare bulb hanging from twisted wire attached to the crate's ceiling. This man has no name in the photo caption. He's not famous. He never will be. But he is as responsible for Allied victory as any general or pilot ace, because without technicians like him ensuring that radios work, all the strategy and bravery in the world accomplishes nothing. You cannot coordinate attacks if your radios don't function. You cannot call for help if no one can hear you. You cannot warn your wingman if the signal doesn't reach him. This anonymous technician, working in a cramped shop built from scrap, maintaining equipment that took 3 years too long to adopt, enabled every successful mission that relied on coordination. The broader lesson extends beyond World War II. How many other technological solutions existed but weren't implemented because of institutional resistance? How many lives could have been saved throughout history if organizations were willing to abandon failed doctrines and adopt proven methods developed elsewhere? The answer is unknowable but almost certainly staggering. Institutional pride kills. Bureaucratic inertia kills. The refusal to admit that your doctrine is wrong and someone else's solution works better that kills more effectively than any weapon. The Germans discovered this same lesson from the opposite direction. German military technology in many areas was advanced jet aircraft, ballistic missiles, advanced tank designs. But German forces never developed effective tactical radio coordination equivalent to Allied capabilities. Why? Because German military doctrine, developed during the Blitzkrieg campaigns of 1939 through 1941, emphasized centralized planning and initiative at the tactical level. Commanders gave orders, subordinate units executed them. Real-time coordination across units wasn't emphasized. By the time the Germans recognized that Allied coordination provided decisive advantage, it was too late. German industrial capacity was collapsing. They couldn't manufacture coordination systems, even if doctrine changed to require them. The institutional failure to recognize technological importance earlier cost Germany any chance of air superiority after 1944. The Pacific Theater revealed similar patterns. The U.S. Navy had been using VHF coordination between fighters and ships since early 1943, using systems like the TBS talk between ships radio for ship-to-ship coordination and various VHF aircraft radios. The effectiveness was immediate. Navy fighters coordinated with ship-based fighter directors could intercept Japanese attacks with devastating precision. The Battle of the Philippine Sea in June 1944, the Great Marianas Turkey Shoot, saw American fighters destroy over 600 Japanese aircraft while losing only about 75 American planes. Multiple factors contributed to this victory, but radio coordination was crucial. American fighter directors could track Japanese formations on radar and vector fighters to intercept before the Japanese even reached the fleet. The Japanese lacked equivalent coordination. Their aircraft attacked piecemeal, uncoordinated, and were destroyed piecemeal. The technology that enabled American naval air defense was essentially the same VHF radio concepts that transformed bomber escort over Europe. Different implementation, same principle. Coordinated forces defeat uncoordinated forces when all other factors are roughly equal. Post-war analysis by military historians consistently identifies radio coordination as a critical factor in Allied victory. Not the only factor, industrial production, manpower, intelligence, and countless other elements all mattered. But coordination enabled everything else to function effectively. You can produce 1,000 aircraft, but if they can't coordinate their operations, they're far less effective than 500 aircraft that can coordinate. You can train the best pilots in the world, but if they can't communicate during combat, they're vulnerable to inferior pilots who can coordinate their attacks. Technology matters, tactics matter, training matters, but coordination multiplies the effectiveness of all those factors. The men who flew with SCR-522 radios in 1944 and 45 recognized this. Their memoirs and interviews consistently emphasize how different the air war felt once reliable communication became available. Not dramatically different in obvious ways, aircraft still got shot down, missions still failed, men still died, but subtly different in ways that added up to decisive advantage. You could warn your wingman about an attack he couldn't see. You could call for help when you were in trouble and actually receive help. These seem like small improvements. Individually, each one is small. Collectively, they transformed warfare. The legacy extends to the present day. Every military radio system used by modern forces traces conceptual ancestry to the VHF coordination systems developed during World War II. The frequencies have changed. Modern tactical radios operate in VHF and UHF bands with digital encryption and frequency hopping to prevent jamming. The technology has advanced. Solid-state electronics replaced vacuum tubes, digital signal processing replaced analog circuits, satellite communications supplement line-of-sight radio. But the fundamental concept remains identical. Give every unit the ability to communicate clearly, reliably, and instantly with other units and commanders. Coordinate operations in real time. Share information immediately. The SCR-522 couldn't do many things modern radios can do. But it proved the concept worked. It demonstrated that coordination multiplies combat effectiveness. Every tactical radio network deployed by military forces today embodies lessons learned when engineers finally built radios that worked and doctrine finally acknowledged that coordination matters. Yet the 3-year gap between solution and implementation haunts this story. Between 1940 and 1943, while American forces struggled with inadequate radios, the proven solution operated successfully in British aircraft. The British offered to share the technology. American engineers were capable of manufacturing it, but institutional resistance delayed adoption until the body count became impossible to ignore. How many of the 21,000 American aircrew casualties in 1943 could have been prevented if VHF coordination had been adopted earlier? We can't know precisely, but we know that lack of coordination was a primary factor in mission failures throughout 1943. We know that after VHF became standard in 1944, coordination improved dramatically and loss rates decreased substantially. The correlation suggests causation. Better radios enabled better coordination, which reduced casualties. If better radios had been available earlier, casualties would likely have been lower earlier. This isn't merely historical speculation. The after-action reports from 1943 explicitly identify communication failures as contributing factors to mission losses. The reports from 1944 note successful coordination. The difference was VHF. The men who died in 1943 died in part because of institutional failure to adopt proven technology. That failure wasn't inevitable. It resulted from human decisions. Commanders who refused to question doctrine, planners who prioritized pride over effectiveness, administrators who delayed adoption of foreign technology because it was foreign. These were choices. The men who died because of those choices deserve to be remembered. Their deaths should teach us something about the cost of institutional pride and bureaucratic inertia. The photograph of that radio technician working in a shipping crate repair shop captures this truth better than any strategic analysis. That young man, hunched over an SCR 522, ensuring it works properly so pilots can talk to each other when they need to. Most, he represents the thousands of people at every level who actually made coordination work, not the generals who eventually authorized adoption, not the planners who finally changed doctrine, the technicians who maintained equipment, the engineers who designed it, the factory workers who built it, the pilots who used it effectively. These people, most of them anonymous to history, enabled Allied victory. They did so despite institutional failures that delayed giving them the tools they needed. There's profound irony in this story. The British developed VHF radio for defensive purposes, coordinating interceptors during the Battle of Britain when they were fighting for survival. The Americans took that same technology and turned it into an offensive weapon, coordinating attacks deep into Germany. Same frequency, same basic radio design, completely different philosophy of use. The British needed coordination to survive. The Americans used coordination to dominate. Both applications were effective. Both saved lives. Both contributed to Allied victory. But the conceptual difference reveals something about institutional thinking. The British, desperate and under attack, tried anything that might work. The Americans, confident in their doctrine and industrial capacity, resisted adopting technology that contradicted their pre-war assumptions. Reality eventually forced change, but only after thousands paid the price for institutional stubbornness. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.